Do this for you instead. What's another word for subtracting or subtraction? Minus. What else? Take away. Take from. Say that again, KT.
Difference.
So all. Tyree said, my bad. So one of those things I do want to say is all of the words y'all said are correct, but for the proper name that we use here, it is called a difference of. What's a way that I could describe these expressions right here? Say again. So it's a difference of squares. That's it. Mathematicians are not original. Usually the name tells you exactly what it is, right? It is a difference of squares based on this right here after we distribute and get that zero in the middle. That's why we call it a difference of squares. It bugged me for the longest time why it was called a difference of squares until, and legitimately, not when I say the longest time, no teacher showed me that in high school, no one showed me that in college. I just realized it when tutoring one day because I distributed and I was like, oh, this makes a lot of sense now. And so again, the only time we get a difference of squares is when factors are the same, one is adding, one is subtracting, because it's going to make that zero in the middle. And it's going to tie into something we study in activity 5.5, or 6.5. Huh? You'll be here. You won't be here for the next unit, but we'll finish up this unit on Monday. Like take a test on it a week from today.
May do it next weekend.
Say again?
May do it next weekend.
Yeah.
I gotta go to the stage.
Okay.
You gonna take a test video.
Well, if you don't take your test, you take a zero. So you better come take that test at some point. All right. Questions, comments, concerns about 2 plus I times 2 minus I? Okay, so two things. So now we're going to look at square root of negative 6 times square root of negative 6. I'm going to go into a couple of really important details with that you'll definitely want to take notes on, and I'll show you which parts. But first off, what I saw most people classify this as was what? Imaginary, because square root of a negative is what?
No. I.
Well, it's imaginary, right? Square root of a negative is imaginary. Can I erase everything about difference of squares? We all good?
Yes, sir.
No one needs me to hold off?
Yeah,
Thank you.
about 30 minutes.
Okay? So I'm going to rewrite square root of negative 6 times square root of negative 6. First off, I'm going to tell you a little bit about how to simplify radicals, which a square root is a radical. First off, does anyone know what I mean by radical? Like what part of this is the radical? That square root symbol. Okay? This square root symbol, that is a radical. There are quite a few different roots out there, but that radical symbol is always the same. For instance, we're not going to go into this, but does anyone know what we call that? I'll point this out, that this is understood to have a 2 here, and it's called a square root. So this is called a cube root. This is called a...
Quad.
So we don't go into names like that. We just call it 4th root. That's it. You can call this a 3rd root as well, okay? So the radical, though, is always there. One thing to be aware of, because this is going to make talking about this easier, this thing underneath the radical also has a name, and it is called the radicand. Well, remember, part of mathematics is communication. So we develop words to be able to more clearly communicate. Because is it easier to say radicand, or is it easier to say the thing that's underneath the radical? Radicand, right? Like that. It's not just like, oh, we're making things up. It's to consolidate our language to be able to communicate more effectively. That's what language is, right? So radicand, that's what's underneath radical. Okay. So, simplifying square roots. Oh, wait a second. So simplifying square roots breaks down pretty easily. First off, factor the radicand into -1 and blank if, what kind of number would have a negative underneath the radical? What kind of number would have a negative under the radical?
Oh, imagine.
Imaginary, right? That's all I'm saying. Is that what you said, Chloe?
Yeah.
I just couldn't quite hear it.
I was kind of scared.
Okay, but it's imaginary, right? You're not always going to have a -1, but if it is imaginary, you will get a -1, okay? 2, factor the radicand further into perfect squares.
So what did blank?
So it just depends on what's underneath the radical. So I'm going to show you an example of this in a second. Good question. So I'll explain more about step 3 in a second. But step 2, are there any terms in there that I need to clarify?
Perfect squares.
Perfect squares. I'm glad that you picked up on that, because I know that's something that causes students trouble sometimes. So when I talk about perfect squares, first off, I will say there's not always going to be a perfect square. Anybody who already knows some perfect squares, can they tell us what they would be? 64 is one. How are we getting 64 though? Why do you know that's a perfect square? Okay, so if you take the square root, it'll give you 8, which means that 8 squared is 64. Start at the very bottom. What's the lowest perfect square? Not 2. There's something before 4. 1. Technically 0, but we don't want to ever use 0. And 1 squared is not going to really help us either, but 1 squared is 1. 2 squared is 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared. Anytime I'm simplifying square roots, I'm going to write out some perfect squares to help me out. Okay? Anytime I'm simplifying square roots, I'm going to write out several perfect squares to make my job easier. Makes it easier to identify those factors. So let's look at the square root of -6. So here's what I meant by that blank, Jaquan. Uh-oh, this one doesn't feel right. Wait a second. And if you want to, you might want to label those numbers as perfect squares. What'd you say, Xavier? Say that one more time. Factor the radicand. Remember, that's what I defined up here, the radicand, that's what's underneath the radical. So don't forget that. So if I'm looking at the square root of -6, I could rewrite that as the square root of -1 times what? I heard someone say it. 6. That's what I meant by the blank, Jaquan. So I factor that -6 into -1 times whatever that is. So that's why I had to leave a blank because it could be anything. So times the square root, -1 times 6 again. And so this is when we get into step 3, separating those radicals into multiple radicals. What I mean by that is square root of -1 times the square root of 6. Square root of -1 times, any guesses? Square root of 6. Right? That's a property of square roots and actually also of exponents that works, that you can separate the one radical into multiple when you have factors. That only works when you have factors, but you can separate that one radical into multiple radicals when you have factors. And so I would get that again. How would I rewrite square root of -1? I times the square root of 6 times I times the square root of 6. Anyone know what the square root of 6 times the square root of 6 might be? Square root of 6 times the square root of 6 is what?
6.
It is 6. Anybody want to ask a question of why?
3 plus 3.
Not because it's 3 plus 3, because remember it's not half, it's the square root. But let me remind you, what does it mean to multiply something by itself? Or what's a way to rewrite anything multiplied by itself?
Exponent.
An exponent, specifically exponent of?
X squared.
If it's only 2 of them, it's squared, isn't it? And what's the relationship between a square root and a square?
They both square.
They are inverses, they cancel, and I'm left with 6. Right? Square roots and squares are inverses. And then we have I times I, which is I squared. And hey, what's I squared again? -1, right? 6 times -1 is -6. If you would type the square root of -6 times the square root of -6 into your calculator, you would have gotten -6. Now, we'll point out, you could have gotten there way quicker. I use this as a background to explain simplifying square roots, but go back to what we said at the end. What does it mean, or what's another way to rewrite something being multiplied by itself? It's what? What's the relationship between a square and a square root? That would have been a lot simpler. That didn't give me the time to show you how to simplify a square root though. But that means that the square root of -6 times the square root of -6 should have fit under what? Integers. Right? Square root of -6 times square root of -6 is -6, that's an integer. Oh, and I forgot to put this here, 2 plus I times 2 minus I is 5. Awesome. Nothing like expo marker all over your pants. Sorry. Got distracted. That was unfortunate. Hopefully this thing comes out. We'll find out. Okay. Well, thanks. Thanks. All right. Which of these do you still have questions about where it might fit? None? For what? That one right there? It's a good question. Let's look at that one. So, first off, I'm going to show you this, or remind you of what we just talked about with simplifying square roots.
Is that 2 or radical?
Not, the 2 is not the radicand. What would be the radicand to be? 24, right? What's underneath the radical?
Oh,
What's underneath the radical? So when I look at that 24, first off, I'm not going to worry about the first step. Why? Because 24 is not negative. But I might worry about the second part with perfect squares. Does 24 have any perfect squares in it?
no.
You sure about that?
12?
Is 12 a perfect square according to this?
No. I'm thinking
Look at those factors again.
4.
4. 4 is a perfect square, isn't it? 4 times what gives me 24?
6.
Uh-huh. Square root of 4 times 6, all divided by 2. Okay. 4 minus what? How would I rewrite that to be able to simplify things? Look at step 3.
Square root of 4 times square root of 6.
We're going to separate that one radical into the multiple radicals according to the factors. So 4 minus what?
2.
2.
And then 3 square root of 2.
So minus what?
It's just, just drop the 6 in.
Right. Remember, we were able to take the square root of 4 because it's a perfect square. Is 6 a perfect square? No, so I can't take the square root. All divided by 2. And I will point out, you can stop here, but traditionally I do go ahead and simplify. I can distribute my division. What's 4 divided by 2? 2. And that 2 divided by 2 creates a 1, so I'm just left with minus the square root of 6. So where do you think that might go?
Probably irrational.
Irrational?
Integer.
Now, I will point out, what is there that might make us think pretty quickly that it's irrational?
The square root.
The square root. Now, does the square root always mean that it's going to be irrational? No. First off, we got to simplify sometimes, but also right here, negative square root of 400 was negative 20. The square root of 121 was 11. So what's special about 121 and 400?
20 is negative.
But that's not what's special compared to here. Preston, what did you say? 400 is a perfect square. 121 is a perfect square. Is 6, 32, or 24, are any of those 3 perfect squares?
No, sir.
Okay, so if we take the square root of a non-perfect square, it's going to be irrational. So square roots of non-perfect squares are irrational. All day, every day. Square roots of non-perfect squares are irrational. Alright? Now I want to point this out here. That 2, if it was just 2, that would be what kind of number? That'd be a natural number. But by subtracting irrational, it makes the whole thing what? Irrational. What if I had 3 square root of 7? Why? The 7 is not a perfect square, right? So if one part of it is irrational, it makes the whole thing irrational. Unless it's like the square root of negative 6 times the square root of negative 6, canceling out that square root. That's important to notice. Similarly over here, if I have 3 divided by 2, just 3 divided by 2 would be what kind of number? Not integer. Why rational? Oops. Not because it's decimal. Say again. It's a ratio. Remember, the first half of the word rational is it's a ratio. If the decimal terminates or if the decimal repeats, that means it came from a ratio. Now we are going to have to clarify that a little bit, but this became imaginary because just one part of it was what? Imaginary. right? We did 2 plus I squared. At the end, we had 3 plus 4I. Imaginary. Even though we have a real part here, we also had an imaginary part, making it imaginary. Okay? One thing I do want to clarify is this. Rational, we already said it's a ratio, but it has to be a ratio between what types of numbers? Because we just saw if it's a ratio of imaginary to real, it's imaginary. If it's a ratio of irrational to integer, it's irrational. Not natural, close. Not whole, not complex, not just real. Because again, that's real. So let me point one more out. -5 divided by 4, that'd be rational. So it has to be a ratio of what's right before it? Integers. It has to be a ratio of integers. It has to be a ratio of integers. Has to be a ratio of integers to be a rational number. Any comments, questions, or concerns before we continue to the rest of activity 6.2? I do want you to look in the book at a couple of details quickly. First off, I want you to notice complex numbers. What's the general form for a complex number? It says in the textbook under activity 6.2. It's what? A plus B I. You will always see me rewrite it to be this way. A plus BI, where the real part is first and the imaginary part is second. And I will point out that those complex numbers can be split into reals and imaginaries. So let's say I have the number -17. How could I write that to include imaginary piece, but it's not, it's still real, it's not imaginary? It's still got to have something I. Wouldn't 1 make that imaginary? So not a 1. Sorry, we did go back to activity 6.2. I forgot we still need to cover some details here. Not a 1. Look at what the details say in the book.
0.
If I put a 0 here, what's 0 times I? 0. So that imaginary part goes away. So that would still be a real number. We want to notice that all real numbers have a 0 for the imaginary part. So if there is an imaginary part, it makes it imaginary. So I want y'all to take, let's say, 3 minutes. That's about what it took in first block. I want you to use the graphic organizer that we filled out on the number system and identify each of these as an always, a sometimes, or a never. So if a number is an imaginary number, then it is blank, a complex number. Actively collaborate, 3 minutes. Let's go. Come on, baby. I need you to wake up, buddy. Look out. Don't worry about what they're doing. You're learning math. Do this Russian really quickly. Come on, y'all. Always, sometimes, never. Read your textbook. It's not this one right here, is it? Sheridan, can you grab that textbook, please? Keyshawn, stop leaving your textbook in this classroom.
Always.
You're right, I stole it and I put it in there.
Always.
It's sarcasm, Keyshawn. You left it here. You had to have left it here. Come on, let's answer those questions.
Number.
What are y'all discuss?
Oh, wait, no, it's always.
Make sure we have a reason for why we pick the answers we do, and that we've collaborated. You always need a reason. There's a claim, you need the evidence for that claim. Yes, sir.
I know.
Say again? For them, it's next Wednesday, Thursday. No, it's not for you. No, y'all are doing a whole other unit after they leave. Oh man, Mr. Key's gonna keep teaching? What do you think you're gonna sit around for 2.5 weeks doing nothing?
Yes.
Alright. Let's go. You won't be here, they will be. So, if a number is an imaginary number, then it is always a complex number?
Agreed.
Does anybody want to push back or ask a question about that? You want to push back? No? Okay. Can someone give me evidence for that statement? Okay. Every number is on the complex? So if it's imaginary, it's fitting underneath the umbrella of complex numbers? Okay, that's good evidence. If a number is a complex number, then it is sometimes an imaginary number? Okay. Anybody want to push back or ask a question? No. Okay. So if you're going to say that, then can someone give me a complex number that is not imaginary? 7, 0. Okay, so all of these numbers under real are complex, but they are not imaginary. Okay. If a number is a real number, then it is always. Anybody want to push back? It's underneath the umbrella, right? Everything is a complex number. If a number is a real number, then it is?
Never.
Never? Why not?
You can't have a real number that's imaginary. Because that's two different
They
categories.
use a real number.
Notice how the reals and the imaginaries are very distinctly split. They do not overlap whatsoever. I will point out the imaginary numbers have a real part to it, right? But as soon as there's an I, whole expression is imaginary, or the whole number is imaginary. Okay, and if the number is a complex number, then it is? Right, because complex numbers can be imaginary and then they would not be real. Okay. Questions, comments, concerns? Okay. So let's do this here. Use the diagram on the previous page. Really, I would use your graphic organizer to look at A, B, D, and F. Please note, it does not just say identify the most specific. It says list all number sets that describe each given number. What I would do if I were you is I would just use the symbols so I don't have to write everything out. Let's take a couple minutes to sort them, actively collaborate. So remember, if it's inside here, right, filled out, remember integers are the whole numbers and their opposites. The integers are the whole numbers and their opposites. So let's discuss. Remember, don't do all number sets that it fits into. Activity 6.2, I think it's number 2. I think that's it. 92 or so.
Are you sure that's it? I'm just playing.
Don't do that.
Calm down. 3 odd is imaginary.
What? Why do you not already have one? What's the issue?
5.5. Wait, you rational. It'll be rational. Yeah, that's
Nathan King?
but he's
They think Charles.
It doesn't have to be the square.
I trust you, but like, I tell you what, I struggle enough to remember first names and last names. I'm not going to.
What is he talking
It's
about?
rational.
Thank you.
This
Thank
was-
you.
is key.
Okay, so 3, I will start, and I will, if I were you, always start with the most specific, because you can just build out from there. The number 3, what's the most specific it can fit into? Natural, right? That's the smallest little box. Natural. What else? Whole. Okay? Whole numbers only add in what set of numbers? Or what number gets added to be a whole number? 0, right? That's the only thing that makes whole different than natural. What else? Integer. Why what? Anything else?
Real.
Is there anything before real? Yeah, remember, the integer is inside of those rationals, right? So it would also include the rationals. What else? Now be careful, look again. Do you see how irrational and rational are separated from each other? If it's a rational, it's not irrational. Notice literally the symbols are reals without the rationals. Okay? So then real and finally complex, right? It's got all of those, right? Every real number is a complex number. Do not forget that. So square root of 7.
Everything got seen.
Anybody want to push back on irrational?
That's right, yeah.
That's right there? Okay. 7 is not a perfect square, so that is going to be irrational. We don't even have to do any work with it. That's what I want you to notice. You would need to explain that detail. This will be on a non-calculator portion. So you need to be able to explain, hey, that number, right? Or the radicand is not a perfect square, so it's irrational. What else?
Complex.
I heard someone say imaginary. Do you agree with imaginary?
Absolutely not.
Who said it?
So